So we just finished talking about learning target 3, or we've been practicing that, which said that if we move up here, I can determine whether or not a set of input and output values represents a function in various forms, tables, graphs, and situations. And we talked about how it's important to know if a relationship is a function or not, because if it's a function, that means we can do certain things with it. And using function notation is one of those things. So I can define and evaluate functions using function notation is learning target 4, and that is what this video is about. When an equation is a function, so think about what a function is from learning target 3, we can write the equation using this notation. And this is read f of x. That's how we read that. F of x equals some equation instead of y equals some equation. This f of x is what we call function notation. This means that the function is called f. So this could actually be any letter. It could be an F, it could be a G. Sometimes people pick a letter here that is based on what the equation is about. For example, if your equation is about the cost of something, maybe you would have C of x instead of f of x. So f is the name of the function, and the x tells you what you're going to put values into it for. So it says, this means that the function is called f, or whatever letter you choose, and we are going to put different values of x into it. However, you can use different letters besides f and x, depending what you want to call it and what you want to put into it. This is helpful if we are working with more than one function. So there are some benefits of using function notation, and on the next page, we are going to talk about 2. It says there are 2 main benefits to using function notation. The first benefit has to do with the f. Now the f is the name of the function. So we could say when there is more than one function, the letter, in parentheses we can say f or another letter. Then we'll write really small because there's only one line. Tells us which function we are using. That's a U right there. Which function we are using. When there is more than one function, the letter, f or whatever letter, tells us which function we are using. And the second benefit has to do with the x. Because remember, function notation looks like this. The f is the name of the function, and the x tells us what the variable is that we're going to be plugging in values for. So the idea is the same. When there is more than one variable, the letter in parentheses tells us which letter to plug numbers into. Okay? So for example, consider these functions. We have function f, function g, and function h. So this is read f of x equals 3x plus 1. G of x equals x squared minus 2. And h of x equals 10x. The x tells us that this is the letter that we're going to be plugging in values for. Sometimes you might have a function that has more than one letter over here, and the letters represent different things. Whatever's in here is what we're going to be plugging in numbers for. So let's look at some examples of this. The first one is f of 4. So this tells us two things. First of all, because that's an f, we're going to be using this function right here. So we can just ignore these two for a minute. So we're using function f, and the 4 tells us that we're going to, instead of an x in here, it's going to be a 4 right here. Because whatever is in parentheses is what's over here. If this is an x, this is an x. If this is a 4, then that is going to be a 4. Instead of 3 times x, it's 3 times 4. And then you add the 1. So 3 times 4 is 12. Add the 1, which is 13. So we can say that f of 4 equals 13. When we plug 4 into function f, it ends up equaling 13. Now let's try down here. We're going to be looking at function h. And instead of the x, we're going to be putting in a negative 2. So instead of 10 times x, now we have 10 times negative 2, which equals negative 20. So we could say that h of negative 2 equals negative 20. Okay. Now lastly is g for these first three. So that means we're looking at this middle function here. And we're looking at g of 5, which means we're going to put, instead of x, we're going to put a 5 in there. So we have g of 5 equals 5 squared minus 2. And notice that when I'm plugging a number into the function, I'm putting it in parentheses. When I put a 4 in here, I put the 4 in parentheses. When I put negative 2, I put the negative 2 in parentheses. And here I'm putting the 5 in parentheses. That's a good habit to get into because it makes it so if this number is ever negative, the negative stays with it. This doesn't look like 10 minus 2. Or this doesn't look like 5 squared, and if that were a negative, it'd be times a negative 1. So whenever you plug a number into an equation, always put it in parentheses, like I did here, with the 4, the negative 2, and the 5, because that will help you from making mistakes later. So first we do exponents when we simplify. So 5 squared is 25 minus the 2. And 25 minus 2 is 23. So we could say that g of 5 equals 23. Now let's look down here. This is asking something slightly different. Now instead of figuring out what these numbers are, we're finding what x is when f of x equals 64. Now remember that when we're thinking about an equal sign, that means that those two things are equal. They can be swapped out for one another. So if f of x equals 64, I can take this f of x, swap it out, and put a 64 right there. So I'm going to find x when this value is 64. So I'm going to solve this equation. 64 equals 3x plus 1. Okay? So I'm going to do that in a really small space right now. There's not a lot of space here, but I need to subtract 1 from both sides. So I get 63 equals 3x because those cancel out. Whenever I'm solving an equation, I undo the adding and subtracting part first from both sides. And now I'm going to divide both sides by 3 because I want to figure out what x is, which means I have to get everything gone around x. So I have to get rid of this 3. Right now it's x times 3, so I'm going to divide by 3 to undo it. So x equals 63 divided by 3 is 21. So when f of x is 64, I know that x is 21. 3 times 21 is 63, plus 1 more will give me 64. Now let's look at this one. When h of x equals 12. So if h of x equals 12, that means I can take what's h of x right here and substitute a 12 in right there. So now I have 12 equals 10x. And then to figure out what x is, because that's what they want me to do, is find x, I'm going to divide both sides by 10. Then I get that x equals 12 divided by 10 is 1.2. Okay, so that's how function notation works. It tells you which function to use by the letter, and it tells you what number to plug into that function by the number in parentheses. And that is all there is to function notation.